In case you haven't heard the good news, both Microsoft Edge and WebKit Safari are now supporting service workers in their preview releases. This is a huge leap forward and sets up 2018 to be the year of progressive web apps. With that being said, what I want to show you today is how to handle touch events that only happen on mobile devices, then use Angular to create animations in response to these events. As you can see here, we run a different animation on this material card every time the user swipes in a different direction. If you're new here, make sure to subscribe, and I recommend that you follow along with the source code at angularfirebase.com. And while you're at it, I also recommend checking out Paul Holliday's YouTube channel and all the awesome Angular content he's creating over there. I'm going to kick this episode off by building a brand new Angular app. Then we have a couple of dependencies to add, the first one being HammerJS, which is used to add support for mobile touch events to your progressive web app, including rotate, pinch, press, pan, tap, and swipe. Then you can install it in your app by running npm install hammerjs flag save. Then once installed, we're going to go into the main TS file and make sure to import HammerJS there. That'll make the events globally available throughout your app. In this demo, I'm using Angular material, but that part's completely optional. You can follow the install instructions on the official repo. The important part is that you install Angular animations, which is included in the Angular mono repo, so you can just install it with npm, and then make sure to include it inside of your app module. So you should have browser animations module inside of the imports array. We're going to be modeling our animations after the animate CSS library, which is one of the most popular libraries on GitHub. The library itself is just a collection of CSS keyframe animations, so all we have to do is port those over to Angular so we can use it with Angular's browser animations module. We don't actually need to install this package in our Angular project. Instead, we're just going to copy and paste the CSS keyframes over to the Angular animations keyframes. The end result is that we'll be able to trigger animations natively in Angular. This will give us fine-grained control over the animation lifecycle, making it much easier to manage the animation state as our app grows more complex. This can be extremely valuable if you're building something like swipeable Tinder cards, or if you just want to optimize the animations for your mobile users. Now that we have all of our dependencies in place, let's go ahead and create a new component called HammerCard. The first thing we'll do is set up the component TypeScript. So we're going to import the necessary tools from Angular animations. Then I'm going to import a keyframes file that has not yet been created, but we're going to do that in the next step. Then inside the component decorator, we'll go ahead and create an animations array. And this is where we define each of the animations as well as the animation trigger. So the trigger is called card animator, and every time that trigger changes, it will transition to a different state. So to define a transition, we use the wildcard, which means any state that transitions to wobble will animate in 1000 milliseconds. Then we'll tell it to animate with the wobble keyframes that we're going to define in that keyframes file. We're going to follow the same exact steps for each of our animations. I have 6 in total in this demo, so we can just add those line by line inside of this animation trigger. After that, we can go into the component and we'll define a variable to hold the animation state. To trigger an animation, all we have to do is define the animation state as a string that matches one of the animations that we defined above. To do that, I'll create a method called startAnimation that takes a state as an argument. Then I'm wrapping it in an if statement so we don't have two animations trying to run at the same time. And after each animation completes, we want to reset the animation state back to an empty string. So I'll go ahead and create another method to handle that. The next step is to define the keyframes that we referenced earlier. So create a new file called keyframes.ts, and you can put this file wherever you want, and it can be shared throughout your application. First, we'll import keyframes and style from Angular animations, and then I'm going to pull up animate CSS side by side so you can see how this is done. All we're doing in this file is exporting variables that define the keyframes that we're going to use in the animation. Each element in the array is a style that represents a relative point in time. In the CSS keyframes to the right, the relative point in time is the percentage, but in Angular, it's represented by the offset property in this object. The basic process is that we convert the percentage to a decimal and add it to the offset property, and then we're also going to copy and paste over the CSS styles from each keyframe. It's a somewhat tedious process, and eventually Angular is going to have its own CSS parser, but for now this is the best way to go about it. To keep this brief, I'm only going to show you this first animation here, but you can find all of the animations in the GitHub project for this video. If we look a little closer at the completed keyframes, you can see we start at 0.2 and then we end at an offset of 0.8. Keyframes need to be ordered ascending based on their offset, and the last keyframe should be no greater than 1. If you remember earlier, we set our transition to be 1000 milliseconds, so it's going to cycle through these keyframes based on that duration of time. With the keyframes in place, let's jump over to the component HTML and start putting this together. So we start with the material card. Then we define the animation trigger by calling @cardAnimator with the animation state. Then Angular calls a done event when the animation is finished. So when it's finished, we're going to reset the animation state back to an empty string. Now we have a whole bunch of HammerJS gesture touch events that we can start playing with. First, we'll listen to the swipe left event. When the user swipes left, we'll call the start animation function and pass it the slide out left animation. For swipe right, we'll use the zoom out right animation. Then we'll also add swipe up and swipe down, but these ones are going to need some additional configuration, which we'll get to in the next step. Then we can go ahead and add the Angular logo and some default text to our card. Then we'll set up a couple material buttons to trigger animations on a button click or tap with HammerJS. A tap is similar to a click, but optimized for mobile devices and can provide some additional metadata for creating custom events. At this point, you can open up Chrome DevTools and run the mobile application emulator, and you should see all the animations running like you would expect. So that's pretty cool, but I still want to show you how you can create your own custom events, as well as customize the behavior of HammerJS. The swipe up and swipe down events are disabled by default, but if we want to enable them, we can import HammerJS into our app module, and then Angular has a Hammer gesture config built into Platform Browser. You create your own Hammer config class, and then you give it an overrides object, which gives you access to the full HammerJS API. You can check out all the options in the Hammer docs, but for now we just need to set the swipe event to direction all. Then to use this config, we need to go down to providers and tell Angular to use our custom class. That'll get the swipe up and swipe down events working, but I want to take this one step further and create my own custom events. This is a perfect use case for an Angular directive, which I'm going to call hammer time. Then to create custom events in Angular, you're going to need host listener, output, and event emitter. First, we'll use the output decorator on a property called double tap, which is equal to a new event emitter. And double tap's going to happen whenever the user taps twice on an object. And then we'll do the same thing for triple tap, which is the same exact thing, but when a user taps 3 times. To create these custom events, we'll first listen to the main tap event coming from HammerJS, and Hammer gives us the tap count for each event. So we can just wrap that in an if statement, and if the tap count equals 2, then we know that the user has double tapped. Then inside the if block, we'll call double tap emit this event. Now the process is exactly the same for triple tap, just looking for the tap count to equal 3. Now our directive is ready to put to use. So we'll go back to our component HTML and add the directive to whichever button we want to listen to these custom events. So you can see here we add another button with the hammer time directive, and then we can listen to the double tap event in parentheses. Then we can run the same start animation function and pass whichever animation we want to use there. If we go back to our app and tap the button once, you can see nothing happens. But if we double tap, then it does the Jello animation. That's just barely scratching the surface of Angular animations and HammerJS. If this video helped you, please like and subscribe. And if you want to take your app to the next level, consider becoming a pro subscriber at angularfirebase.com. You'll get access to a support network designed to help you get your app built and shipped into production, as well as a free copy of my book and access to exclusive content every week. Thanks for watching, and I'll see you soon.